Hi, it's Balázs from Alpha Forever here, and this is AFNoding number 32. And today we are going to build a shift register, shift register, shift register, or register. I don't know how to pronounce it well, but yeah, I should have googled it. Anyways, we are going to build this little device that you may know from analog devices, or maybe from an OG2. It's basically 8 pieces of memory that pass the value that they store to the next one in the row. So let's jump into our favorite piece of software, Ableton Live, and start to build something. So let's imagine that we have 8 outputs. Here's 1, 2, 3, 4, 5, 6, 7, 8. And imagine that we have a value here, and that's maybe 1, and all the others are 0. And if a trigger event happens, then this 1 goes to the next output, and the first one is receiving a new value. So, and if another trigger happens, the first value is going to be on the second output, and the second output will become the first, and the first is getting a new value. That's why it's called shift register, because it shifts the values from the first input towards, or from the first output towards the last one. And yeah, probably you can create some canon-like sounds with it. And I will start to build one now, and we'll start to do something that makes sense. So we have one output and we need an input, so we will need some value that we wanna store somewhere. And if we store values, we usually use a variable or an array. But in this case, I'm sticking to the variable, and because of we are using the variable, this thing is going to work properly only in effect mode, because in polyphonic mode the variable does not store the values that will live on each polyphone, so it would cause strange things. So we will need a variable mono, but we don't have that node yet, but later on we will. For the time being, this shift register is only on the effect mode there. It will only work properly there. So we will want to output this value, and this is going to be our first output. And we will need to store somehow, so we need an event which is going to be a trigger. And there it goes. This is the most basic thing we can do, and it's probably it. So we need 7 other outputs. So what's happening on output 2? If the trigger signal happens, then we want to have this variable active as well, and the output is going to be the value of this variable. And how do we know what we want to store? So this trigger event happens, and we want to store the value that this variable, the first variable had, but one sample before the trigger. So we are going to use the node called previous, which is a 1 sample delay. Insert it there, plug it here, and basically this is it. So this should actually work. And let me move these guys to the side so we can copy paste it easily. So this is going to be number 3. Number 4, and we can go to 8. So this is 3, 4, and let's copy the from here. So 8 is a bit 4, 5, 6, 7, and one more. Copy paste. My mouse wheel is behaving strange, anyways, doesn't matter. number 8, and yeah, this is the bus for the trigger. Cons are useful to create buses. And actually, this is the shift register. It was not that complicated, and it's done. It's really this much. I can call this shift register, and this will work. So actually, I could end this session here, and let's use it. But I think it's better if I show it, or show how it works. Or yeah. So let's create something that will make sound. And probably you know me, I'm not that much the guy who is using oscillators all the time, but now I will. So I want to create a triangle oscillator, a simple triangle, bandlimited triangle. And here our input is going to be the pitch, and we will need we will multiply this by an envelope follower, where we are going to use release time as an input, and yeah, it should be 0.5 here, I think. So yeah, basically we are fine here, and I output this, and yeah, this is going to be a basic synth. So this is really a basic synth, just needs a knob, and this is the release. Let's say between 0 and 2000, like this, should make sense. And let's pack the first input here, and the output should go into gain in. Use a con, and create the outputs, and we are fine. And I'm going to create a MIDI node, connect the trigger to the trigger. For the time being, that should make sense. And for the input, I'm going to put the MIDI node here. And if I hit a key on my MIDI keyboard, you should hear something. I don't know if it made a sound. I think probably it didn't. And the reason is that I didn't connect the trigger here, because I forgot about it. So let's plug the trigger there. I'm going to bypass it from here. So I'm going to use this. Yeah. So this is the first output. If I duplicate this little synth, this, I just cleaned the patch up a bit. You know, I like to align these guys. So now I will need a mixer. And now we will hear two sounds if I plug in the fourth. And I can add one more synth if I want to. So I just need to plug in the values, and I can use the third memory slot and plug it into there. And so it's fun anyways, even this way. But we can also create something like a switch of 8. And let me delete these two synths from here, because this will be a bit different. so I can plug in the switch, so plug these guys into the switch, and simply this is going to be the input of the synth. So this is the pitch input. I call this P, I don't know why I didn't do that. And this is still the release. And instead of the trigger, I'm going to load my smooth clock patch that, as we know, outputs the clock position and it won't jitter. And you can find this patch in maybe 3 or 2 tutorials before, so it's maybe AFNoding number 29 or 28. And yeah, if this clock, so I multiply this by 4, so we have 16th notes, and truncate it so we don't have decimals, or we only have decimals. Actually, that's confusing me a bit now. I'm Hungarian, bear with me. And then I modulo it by 8. And I give this to the input of the switch. And also, if this value is changing, we will use the trigger. And yeah, this is this is something like an arpeggio. And if we create another switch, but mess up the order, let's say by 1, or use the same connection, that's maybe a bit more intuitive. 3, 4, 5, 6, 7, and 8. And replace this part and simply add some value before this, and it's going to be a step value between 0 and 16 probably. And if you plug this here and create another synth, same pitch, same release, same trigger source, like this, and plug it there. And if I give this some volume, and if I can shift the second, the order of the second switch. And one more thing we want to do is to use the same clock source on the shift register. So we use the clock for storing and shifting values, so we are always in time. And this looks like a feedback which disturbs me, but I can live with it for now. And no, this wasn't right, because now we are always shifting, and not only if we enter a new note, so we need to take care of this. So actually it's better to use the gate and multiply it by the output of this change node. So if we hold the key while this clock event happens, then we will have a trigger. Let's see if this works. So yeah, these are the basic ways to use a shift register, or shift register, or I don't know how to pronounce it still because I didn't Google it up since then. Anyways, I hope you had fun watching this, and I hope you will have fun with this node. And yeah, this was AFNoding number 32. We built a shift register, shift I don't know. And yeah, if you have fun watching this channel, then please subscribe and give Alpha Forever a try. We think it's worth it. And yeah, thanks for watching, guys. Bye bye, happy noding.